So in this problem, obtain the bending stress value at point A, B, C, D for a section shown in the figure. It is a Z section. Compute the stress using moment value with respect to X and Y axis and principal axis. Right? We are going to solve this problem in the method of principal axis method. So the given data are, it is a Z section. So they are given a reference axis in the midsection of the second element and they are cutted here, and mx, the mx equal to the given value acting mx 1200 kilonewton centimeter, and my will be 120 kilonewton centimeter, right? My. So we have three element. Let us consider in Z section this is element 1. So we will cut here, and this is element 2 and this is element 3, right? So the data are mx 1200 kilonewton centimeter, my equal to 120 kilonewton centimeter. We have to find stresses in the bending stress. Let us consider bending stress in the A, B, C, D. Let us consider A corner point, B corner point, C and D corner point. We need to find using principal axis method. So before we seen the K method and neutral axis method and principal axis method. So similar fashion we have to find out the Ixx, Iyy, Ixy. Then we go for the principal axis moment of inertia formulas. So what is principal axis? Principal axis, the associate coordinate axis are called the principal direction of the cross section. If you take any cross section, the principal axis is one where the bending moment about one axis does not result if any deflection or perpendicular to the axis. Okay, so there is no interaction between the two axes. We will call it as I moment of inertia with respect to xy equal to 0. So we let us see the value for this problem. How it is we are getting the value. So before going to the problem, we will recall the principal stress formulas. Principal stress formulas are, so we need to find out the principal stress angle pi. So tan 2 pi equal to 2 Ixy divided by Ixx minus Iyy. This is the formula for the principal axis angle. As per our definition, the product moment of inertia is equal to 0. It means Ixy equal to for principal axis integral of xy dA equal to 0. So if you solve the problem for a principal axis, Ixy will be 0, right? Let us see this will come. So formula for you need to find the Ixx for principal axis is equal to Ixx cos square pi plus Iyy sin square pi minus 2Ixy sin pi cos pi. So we need to identify Ixx, Iyy, Ixy in Wolder method. So we need to by using of this tan 2 pi formula, then we will calculate this pi value. Similarly, Iyy p, that means Iyy for principal axis, Ixy for principal axis. If you calculate this value you will get 0 if the problem is solved by using principal axis method. So then mx cos pi minus my sin pi. For myp, my cos pi minus mx sin pi. So x comma y for the coordinate points for the principal axis for each corner. The x cos pi plus y sin pi. yp equal to y cos pi minus x sin pi. This is the formula which recalling of our principal axis method. So now we will go to our problem. See, we will find out we will form the and step on elementary table. In elementary table, we have three elements. We splitted this Z section into three elements: element 1, element 2, element 3. And we are taking the data, entire data. Here they are giving the value of up to this axis only. They are giving 10. So we need to add this remaining portion 0.2. So why? Because the entire cross section of the thickness is 5 centimeter. So we are at this 5 centimeter, this 5 centimeter, this 5 centimeter thickness, and this is 10. The axis will goes here. 10 plus 2.2, 12.5. Similar fashion, that entire length of the element 2 will be 20 centimeter because up to here to here 10 centimeter, up to here 5 goes means it will come 10 and remaining 10. So we have add 20 for the element 2. Similar for the element 3. So in this we have to find out the area. It is rectangular, so L into B will get 62.5. Same value will become for the element 3. So in element 2 it is 20 into 5, then we will get 100. So then we need to find out the x comma y. So already they given a reference axis of mid of this element 2. So absolutely for element 2 it will be perfect rectangular. So you get 0 comma 0 for element 2. That's why x y 0. For element 1, so we need to put the axis here. Axis will goes here, right? So we need to identify how much distance thus for element 1 will be having. So entire length will be 12.5. Half of this will be we need to calculate half of this value will be, then we need to minus this entire value. So 3.275 plus 2.5, then it will get minus, this minus 3.75. So that is what we are getting the x value. Similar fashion from the reference axis, what is the y value? We are getting 12.5. Then x is second element to 0. Third element, it is there in positive case. So plus and 2, y will be minus 12.5. Then we need to multiply ax, ay, ax square, axy, ay square, icx, icy. This will do the mathematics, and we need to concentrate on sigma sign. Whether x is coordinate means this is we are splitting this into 4 quadrant. So definitely the element will be getting minus x plus y. This element will be 0 comma 0. This will be 4th quadrant. So we have plus and minus y, right? So for ICX, ICY, we need to calculate for each element. So element 1 will take it out, element 2, element 3. ICX, ICY. ICX means B dq by 12. ICY means D bq by 12. You take the element 1, we have B and D. This is B. Absolutely, if your x-axis is B, this is D for any cases. Like this, if you take for element 1, this is B, this is D. Element 2, this is B, this is D. For element 3, this is B, this is D. Okay. So for element 1, B dq by 12 equal to 12.5 into 5.3 divided by 12. We will getting 130.208 centimeter per 4. Similarly for ICY, D bq by 12. D will be from the same diagram. We have D equal to 5. B equal to 12.5 q by 12. Then 813.80 centimeter 4 we are getting for element 1 ICY. For element 2 we are getting B dq, same formula, B dq by 12. ICY D bq 12. So for element we need to identify this is the B. Always x will be the B. B entire things will be D. So 5 into 20 q by 12. So we are getting 33.3 centimeter per 4. D bq by 12 for ICY for element 2. 20 into 5 q by 12. Then 208.33 centimeter 4 we are getting. Similar for the element 3. ICX for ICY we need to find out. B dq by 12. D bq by 12. So this is B, this is D. So B will be 12.5 to 5.3, 5 q by 12. Then we are getting 130.208 centimeter per 4. For ICY, D bq by 12, 5 into 12.5 q by 12. Then we are getting 81380 centimeter 4. This is as usual what we are doing to filling this elementary table. If you filled out this elementary table, then we will go for the IXX, IYY, IXY formula. Generally we know summation of ICX plus summation of AY square minus summation of AY bar square. So for this this is unsymmetric, but the axis passes to the center of the axis. So then definitely absolutely if you go for x bar and y bar, summation of AX equal to 0, summation of equal to 0, then we will getting 0 value. So already it is there in the centroid x bar comma y bar axis. So this x bar terms, y bar terms will get 0. This entire terms will get 0. Remaining term ICX we find out for summation value, AY square summation value. IXX we getting 23124.95 centimeter per 4. Similarly, IYY equal to summation of ICY plus summation of AX square minus summation of AX bar square. 0 terms come. So summation of ICY equal to 1835.9 plus 1757.8. We are getting 3593.7 centimeter per 4. This you have to do in calculation. Then only you can get the exact value. Then we are going for the IXY equal to summation of AXY minus summation of AX bar y bar. So absolutely this terms get 0. Then minus of 5859.37 equals 0 minus 5859.37 centimeter. You have to be careful on this minus value. This will be impact on that. So this is the common for all K method, principal axis method and neutral axis method, right? This up to this. Next here we are going to solve the problems on principal axis method. So we need to find out what is the principal angle. So tan 2 pi equal to 2 ixy by divided by ixx minus iyy. Here we find out the ixx, iyy we find out that. So this minus is indicating here, minus into 2 into minus 5859.37 is iy divided by ixx value, iyy we put it, and we are getting minus this value. The value of this tan 2 pi equal to minus 0.5999. So we have to getting the angle means tan inverse of this value, minus value, and 2 pi equal to minus 30963, this will getting. So pi angle will be minus 15.48. So finally we are getting the principal axis angle pi equal to minus 15.48. So now we got the value of principal axis angle. Now we are going for the moment of inertia for each principal axis. I mean ixy principal, iyy principal, ixy principal axis we need to find out. Then we will go for the bending stress formulas. So here we are finding the value of ixx principal axis. So far we are finding ixx, iyy, ixy for the common for reference value. Then ix principal axis means ixx cos square pi plus iyy sin square pi minus 2. So here minus will come 2 ixy sin pi cos pi. So we have ixx, iyy, ixy value substitute here. So this is cos square or cos pi with the whole square. So this is cos square pi. So cos square minus 15.48, and similarly sin square pi, sin pi cos pi. We are getting if you square this value, we are getting 23124.95 into this cos square value. This we have this ixy formula in terms of 2 times of value, and we are getting this entire ixy principal axis will be 18718.73 centimeter power 4. Right? So similarly we need to find out the principal axis, iyy principal axis. So iyy cos square pi plus ixx sin square pi, plus here plus will come 2ixy cos pi sin pi. So we are going to substitute iyy here. Iyy will come, ixx will come, cos square pi sin square pi, 2 times of ixy, this minus term will there, cos pi you are getting in terms of cos minus angle, and sin pi. So if you solve this mathematically, you are getting iyy per principal axis we are getting 7998.14 centimeter power 4. Unit is must. You kindly do put your units while solving the problem. And next we need to find out the ixy principal axis is equal to. So this will say that whether we are solving the principal axis, we need to get the value of 0. So principal axis means ixy principal axis definitely should be 0. So we have the formula ixx minus iyy cos pi sin pi minus ixy cos square pi minus sin square pi. If you substitute all the ixx, iyy, cos pi values, everything, if you get 0, that so far what you have done is your values are correct and you are going in a correct path and using the values what you find out the values are correct. So ixx, iyy we have put it, sin pi, cos pi value we put it, I minus of ixy, cos square pi and sin square value substituted. If you change any minus, you have missed any minus means definitely you will not get any 0 value. So definitely you get value. You should get the 0 so that you are solving in principal axis method. Your formulas are using and whatever you are solving, getting values are in correct way. So if you substitute minus 52.3.82, that's 50.24 value. If you get 0.58, it is nearly 0. It is nearly why? Because if you take all the point value, then you will get 0, exactly 0. So it is 0.58. So we, as per our principal axis method, we are getting ixy equal to 0. Okay. Then we will go for mxp. Mxp equal to, we need to find mx, we know my, the given values are there, mx and my in terms of kilonewton centimeter, we will change this in Newton centimeter. So mx cos pi minus my sin pi, we will substitute all the value, and mx principal axis will get 1.88.428 into 10 to the power of 3 Newton centimeter. Right? Similarly, we have to find out the myp equal to my cos pi plus mx sin pi. So here minus will come, here plus will come. So you need to memorize or you need to understand the formulas while solving the problem. Then you will get mx will be 120 into the power of 3 cos this value pi value, and here plus mx sin pi value. So if you solve this, don't forget this putting the minus values. Why? Because cos pi will different, cos sin minus pi and sin minus pi will different, totally different. And you are getting mx equal minus of 204.64 10 to the power of 3 Newton centimeter. So we know the formula for principal axis or general method, sigma is equal to m by I y plus my by I x. So So this is in terms of principal axis, that why PP we are putting here for notation. Mx we know, Mixx, Iyy into y, My, Iyy into x we know. So substitute Mx, Ixx, My, Iyy. These are values are mathematically we have to put here. Don't forget the 10 to the power of 3 values, or don't miss any values here. If you put, then you will get stuck, or the answer will be wrong. So Mx, Myp, Iyp we have, xp equal to, we need to find out what is, this is principal axis y, principal axis x we need to find out. So sigma equal to, we find out the equation in terms of x and y in terms of p. So we need to find out what is x, what is y. That we have a separate formula for x comma y for the principal axis method. So we'll go for, we know the formula, yp equal to y cos pi minus x sin pi, xp equal to x cos pi plus y sin pi. So we need to find the coordinate table. This value you need to find out from the diagram. Then only you can able to understand this x comma y value, right? So we need to get the for A section what is the corner point, what B section what is the corner point, for C section what is the corner point, for D section what is the corner point. This is your x bar comma y bar. That means we are getting 0 comma 0. From this, what is the x comma y for A point? So if from graph, what is the x comma y for A point? What is x comma y for B point? What is x comma y for C point? What is x comma y for D point? That is why we are getting. So you need to find. We want to put the minus whether we are in first quadrant, second, third quadrant. So A is in second quadrant. So minus 10 distance, and height will be 15 positive y. So B will be positive 2.5 x, positive 15 in terms of y height. So C will be in both in third quadrant. So third quadrant we are getting minus 2.5 and minus 15 for the C point. D point will be minus this is plus 10 and minus 15 for the y. So that is what we are getting x comma y. So we need to put the each section. This is for A, B, C, D corner. So XP for stress at A point we need to find out. That for that we need to find what is XP, what is YP. This is for A. XP equal to, we need to put, this is for the formula we know. X value is minus 10, this value, and Y will be the here we have to find out. Similarly, we need to find out the for YP. So we are getting both XP and YP in terms of centimeter. So finally, we need to substitute all the X and Y values to the sigma Z formula, that we have the sigma Z formula. For A section, we need to XP and YP we need to substitute. So sigma A equal to, we substitute XP and YP value, we are getting stress at A point due to the principal axis, from the principal axis, right? So B, similarly for stress at B point, so we need to find out x comma y for the B point. For that we are using the same formula, the use of table. We have to putting the x comma y value, and we are getting xp and yp, and finally we are arriving the sigma p, sigma b value at p from the principal axis. We are getting 0.9 at 10 to the power of 3 Newton per centimeter square. So at last we are going for the stress at the C point. Stress at the C point, that x comma p, xp comma yp, you need to find out using the coordinate tables. Sigma p is the formula, so we need to substitute both the xp and yp from the C point, and we are getting 1.3786 10 to the power of 3 Newton per centimeter square. Similarly for D section, xp comma yp you need to find out. So this x comma p, x comma y value you need to substitute sigma d, and we are getting 1.0886 10 to the power of minus plus 3 Newton centimeter. At last we are getting the values of, the results will be principal axis angle, stress at the point A, stress at the point B, C and D we identified. So recalling these things, we will go for the recall of the entire problem. This is a little bit time taking problem that you need to practice well, then only you will get the time in the examinations, right? So if you solve this problem, or if you understand this problem, the remaining problems are easy. Try to solve problems using in K method, that will be very easy, and try to solve the problems in Boom's problem. Once they are giving this is 3 sections, so it will take time taking process. So try to solve the problem which is a less section, or if the problems based on Boom's means, you will solve that problem, right? So they give in this problem, they give in that section, the mx, my they given. We have to say what is the principal axis method we are going to solve, and that we need to find out the elementary table, that a, x, y, we need to, if you fix this value, this is the value, people will make the mistakes. The minus plus they will solve, they will miss, and the x and y, they finding x and y, they will have difficulty. So if you complete this area, then remaining terms are very easy. That's just multiplication, and that second part is ICX, ICY is another part. So you have to understand that this is a B, this is a D. For x will be any cases, any size, any shape. This is a B, this will be D. So this BD, BD. This for this BD. Okay. For element 1, we need to find out ICX, ICY, BD cube by 12, DB cube by 12. Similarly, for element 2, element 3, we need to find out the BD cube by 12. Then we need to find out the IXX, IYY, IXY, the basic formula what we have from the eliminated table. Then we are going for the principal axis method. Tan 2 pi equal to, we have 2 IXY by IXX minus IYY. This we have to substitute, and we are getting the principal axis angle. Then we'll go for IYY principal axis, IXY principal axis, right? IXP principal axis. If we get to 0, then we are going in a correct path, that we are getting IXY 0 means we are solving problems on principal axis, and we are getting MXP, MYP we need to find out. We have the separate formula. MYP equal to MX cos pi minus MY sin pi. MYP equal to MY cos pi plus MX sin pi. So we are getting the formula sigma p equal to mxp divided by xxp into yp plus myp by yyp xp. So these are p are indicating the principal axis. Mx formula we know, ixx formula we know. So xp, yp we need to find out. That for that we need to find out the coordinate tables from the centroidal value, and x comma we will find out each coordinate, which coordinate they are asking, and each stress we have to find out the xp, yp, and we have to substitute in the stress formula, and we will get sigma AP equal to the value, and similarly for B, C and D section. Finally we are having this results for pi equal to minus 15.48, sigma AP equal to 1.092 10 3 centimeter square, sigma at B equal to 0.986 10 3 centimeter square, sigma C equal to 1.3786 10 3 centimeter square, sigma D will be 1.0886 10 3 centimeter square. So kindly in this first unit you would kindly work on these problems: Z section, T section, C section, angle section, thin walled section, which is T is very very small. Then we'll remove the T cube equal to 0. That you have to practice. And the boom problem, boom they have the structure idealization. We are for the n number of members, n number of elements, we are making it a single element. We have to practice that element problems, that is in stringers or boom problem, that you don't need to calculate the ICX, ICY. Directly you can put the area they will give x comma y. If you find out that, then that will be the easiest problem in the first unit. So far we completed in the first unit. So you practice this problem. We will go for the second unit in the next class. Thank you.